the next mistake that I see students make, and that is going to be forgetting their asymptote. So, ladies and gentlemen, asymptote, I don't know why I was, there we go. All right. So when we're looking into graphing a asymptote, we have y equals ln of x. All right. I'm just going to use a parent graph. It's very, very important to remember what the parent graph looks like. So we know that's going to have an x-intercept at 1, 0. Okay. But even though an asymptote is not a part of a graph, ladies and gentlemen, we still need to make sure we include it, right? Because that is going to be the value that our graph is going to be approaching. I want to make sure this is red. So we need to make sure we are including that. So whenever I was having students on a test or a quiz and graphing, I always made sure, guys, remember, do not forget those asymptotes. Make sure that you guys are graphing them, applying them in there, because we'll talk about this as a mistake later in this video. But it's very, very important to make sure you are defined where this graph is going, because especially if you're a little lazy or you're a little bad with your penmanship, this line could not look like it's actually approaching this asymptote. So I see students get marked down all the time for getting their asymptote. So let's just kind of do another quick example of another equation. Like if I had y equals a 3 minus ln of x minus 2. Now there's a couple important things to understand. The asymptote is only going to change. It's only going to move if we have horizontal shifts or horizontal shift to the left or to the right. Okay. Anything we're doing up or down, it's not going to matter. Any reflections, left or horizontal or vertical stretches or compresses, they're not going to move the asymptote. So all you really need to understand is just know, okay, what horizontally am I happening here? My graph is being shifted 2 units to the right. So what's important when you're graphing, what I always tell students to do is there's 2 things I want you to work on. One, I want you to apply the transformations to our x-intercept. So if I was to write this in the transformation form, I would say negative ln of x minus 2 plus 3. So I'm going to take this point, which is the original x-intercept of my parent function. I'm going to shift it 2 units to the right, and then I'll shift it 3 units up. So 1, 2, 3. And then also I have my asymptote has been shifted 2 units to the right. So what I'm going to do, instead of having my asymptote right here, I'm going to move over 2 units and put my asymptote there. Now, obviously you can see we have a reflection about our x-axis. So my graph is going to look something like that. But hopefully you guys can just see it's so important to make sure you include that asymptote so your teacher can identify where those undefined values are or where your graph is going to be approaching. All right.